Hi everyone, we're going to find all the critical numbers for f to help us to identify all relative extremum. Critical numbers don't guarantee extremum, but they're useful in finding the open intervals where f is increasing or decreasing. So the first thing I'm going to do is rewrite this. As you recall, sine of 2x equals 2 sine of theta times cosine of theta. Since I don't have a 2 in front of here, I'm just going to rewrite this as 1/2 sine of 2 theta. That way, if I expanded it back, I get back to my original. And then I'm going to go ahead and take the derivative of this. So you take the derivative of this, you're going to get the derivative of this is going to be 1/2. The derivative of sine of 2x is cosine of 2x. Then you have to take the derivative of the inner function part here, and that's just going to be 2. Well, 2 times 1/2 is just 1. So we're left with cosine of 2x, and we set this to 0. So the critical numbers are going to be x equals, we have to go from 0 to 2 pi, and I know that this would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. We know that cosine of x is 0 at actually pi over 2 and 3 pi over 2. So basically, this is 4. So basically, to plug it in here and to get that 0, we're dividing these by 2. Alright, and then you have to get all the intervals. So that would be pi over 4, 3 pi over 4, and then you have to get all the intervals all the way to 2 pi. So that's why we have 4 critical numbers here. Now, we're going to do test intervals. So let me write it here. Our critical numbers are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So our test intervals are going to be from 0, let's see, I'm going to have 6 intervals. So I'm going to write these like open intervals to save room. So we have 0 to pi over 4. Still not going to have room. So then we have pi over 4 to 3 pi over 4. Try to write smaller. Then we're going to have 3 pi over 4 to 5 pi over 4. And then we have 5 pi over 4 to 7 pi over 4. And then finally, let me squeeze in here, 7 pi over 4 to 2 pi, which would be 8 pi over 4. Okay, so we're going to do our sign here, and we have the derivative of x equals cosine of 2x. So basically I'm going to do the midpoint here. When I plug in, if I do the midpoint between these two values, you get pi over 8, which is 22.5. If you plug that in, my derivative is positive. And then when I plug in, say, if I add these two, so what I'm doing is I'm adding pi over 4 plus 3 pi over 4 and dividing by 2. That's going to give you pi over 2. So you plug in pi over 2, you get cosine of pi. Well, cosine of pi is -1, so that's going to be negative 1. And that's how you kind of do it. You just get midpoints. This one would be 8 pi over 8, which is just, you add these up, divide by 2. In this case, we're going to get 8 pi over 4 divided by 2. So that's going to be positive. And this one is going to be negative. And this one, the last one, we're going to get back to positive. So it's going up and down, up and down. You also could just probably graph this and see where it's increasing. You already know what cosine looks like. And so we know we have two waves between 0 and 2 pi. One wave between 0 and pi. And we know we start here. So we have something like this. And you can kind of get an idea, and then just do it again. So where it's increasing and decreasing. But anyway, so basically this is increasing, decreasing, increasing, decreasing, and increasing. And our intervals would then again be 0, pi over 4. It's increasing and so forth. And you can just copy these down right in here. Alright, so it's increasing on 3 intervals, which would be these 3, and decreasing on the other 2. Now for the maximum and minimum, we're going to plug in to our original equation, and our original equation was f of x equals sine of a, we'll just do this one, 1/2 sine of 2x, and so we're just plugging in our critical numbers. We're going to plug in pi over 4, and we're going to plug in 5 pi over 4, and that's going to equal, when you plug that in, for pi over 4, you're going to get 1/2, and when you plug in 5 pi over 4, you get 1/2. Okay, and then for the, so that's going to be your relative maximum. So you have pi over 4, and at the end here, that's where it's increasing. So you're going to have a maximum. It's also increasing right in here. So that's another maximum. So our relative maximum are pi over 4 comma 1/2 and 5 pi over 4 comma 1/2. And for the minimum, we're going to be looking at where it's decreasing. So here it's decreasing, goes back down. And then here it's also going back down. Right in here. So for our this is our maximum. Then so for our minimum, we're doing f of 3 pi over 4. And we're also doing f of 7 pi over 4. And when you plug those in, you get negative 1/2 and negative 1/2. And again, you can write it as an ordered pair. But this would be your minimum. Again, it helps to draw the graph because it's decreasing in here and it starts increasing up here. So that's for the 7 pi over 4 and the 3 pi over 4. Okay, thank you. Have a nice day. Bye-bye.